just to briefly kind of show you the personnel here. So this is going to be chaired by Jonathan McDowell, and we have some excellent people, Moriba Jah, Hugh Lewis, and Alan Thompson. So I'm going to hand over to you, Jonathan. Let's talk about space junk.
Just introduce myself. I'm an astronomer at the Center for Astrophysics, Harvard and Smithsonian, part of the Chandra Space Telescope team, but also the author of Jonathan's Space Report, a satellite newsletter on the internet. And my first question is going to be to Professor Moriba Jah from the University of Texas at Austin, who is an expert on astrodynamics and space tracking. And so, Moriba, we haven't had a big orbital collision in over 10 years. So why do you think it's a problem? Is it really a problem?
Yeah, thank you so much. Hello to everybody present, and hopefully everybody is safe and healthy. Look, I think that there's the whole unknown unknowns. I mean, clearly we see when there's an increase in trackable stuff, you know, in the US catalog for sure, and other people's databases. So we can kind of tell when things break up. You know, yeah, we haven't had a big collision since then, but I think it's less of a matter of if, but rather when we're kind of due, especially with the increase in traffic. And certainly, I think that people tend to focus on the debris creation, you know, specifically on collisions, and that's like the big thing dominating people's, you know, radars, pun intended. But I think that people just don't include the fact that things do explode, and we've actually seen a few explosions just in the past few years of larger rocket bodies that have created lots of debris in geotransfer orbits that, oh, by the way, now this is a highway of junk that's going to connect to geo as the geotransfer orbit precesses, you know, due to perturbations. And also, you know, the fact that objects age in space in ways that we fully don't understand, and things break up on their own. So things, you know, glue isn't meant to last forever, and due to thermal cycling and material fatigue, things crack and they just break apart. Maybe they weren't designed out of unobtainium. So I think these are some critical things that people need to take into account, and that's why it's important.
Thanks, Moriba. And I'm going to ask Professor Hugh Lewis from the University of Southampton. He's an expert on space debris modeling and serves on the Interagency Space Debris Committee. And Hugh, first I want to ask you, is there a real danger of a chain reaction like in the movie Gravity?
Hello, Jonathan. Thanks very much for the question. It's a really good question. It's one that I get a lot, actually. So I'd like to make a distinction really between what was depicted in the film Gravity, which actually is a story over 90 minutes. If you tried to follow the physics of how this process might work, you'd be sitting in that movie theater probably for some hundreds or thousands of years waiting for it to happen. But the depiction actually was probably not too dissimilar from what you might see. Now, a really good way to imagine this is to imagine a domino toppling world record, okay, where you've lined up lots of dominoes, you knock one, and then you wait to see all the dominoes fall over. Now, lots of people think of that as your typical collision cascade. You need one collision to happen, and then you get this chain reaction of collisions that take place. But the reality is, it is not really like that. Another analogy is popcorn. When you cook popcorn in a pan, everything gets warmed up, and then all of a sudden, all of the kernels just burst. Okay, and again, that's at another extreme as well. And the reality of the Kessler syndrome is probably somewhere in the middle. It's probably more like you trying this world record domino toppling event and, you know, having lots of false starts and having bits and pieces of the pattern you've laid out on the floor falling over at different times, not when they're supposed to, and so on. So So it's a real problem that we can expect to see collisions that will trigger other collisions. But my expectation is that we don't see this really long chain of collisions taking place.
And now I want to introduce Alan Thompson, who is the head of government affairs of the British rocket launch company Skyrora. Very exciting, and he has an extensive background in international trade and development. Alan, you represent a launch operator. Is it going to be hard to launch things with all of this traffic going overhead?
I think that's a very good question. It's a challenge, and I'm delighted to be part of this discussion today, and thank you very much for the invitation. The approach that we're taking to that is actually through responsibility and the collaboration, and a number of themes that have been mentioned by colleagues earlier on this evening. I think, particularly from the point of view of Skyrora, we believe that the way to go is to come up with a code of responsibility for the launch partners that we are looking to assist into low Earth orbit. And that, I suppose, that's the beginnings of our thoughts. Obviously, we're still waiting for the UK regulations to come into force to be able to do that on a regular basis. And we're hoping that that will be from, again, the end of 2022, when we'll finally get to start launching. But yeah, I do believe that at the moment, obviously the sheer numbers of space debris, and indeed I think the image that Andy shared at the very beginning of an item of space debris hitting into the International Space Station and causing the dent, I think obviously we're talking about debris which is larger than 10 centimeters, which is probably the most impactful. But I do believe at the moment that there is still sufficient space, there's still sufficient area up there that it will not be a challenge to start launching. But I do believe that going forward, again, referring to some colleagues' comments about replacing one satellite up, one down, that's something that Skyrora specifically is looking into doing, which is also to removing satellites from orbit, utilizing a third stage that we have, which is coming to be an orbital maneuvering vehicle. So I think we're erring very much on the side of responsibility. We're very keen to play our part and actually to engage to understand what and to measure the risk, to understand the risk better, both on a side of trying to get into a practical side of things, tangible. How can we measure this risk, and yet at the same time to react and not to be the antagonists to the astronomers out there and just irresponsible behavior of launching satellites into orbit.
Thanks. And I think I may have accidentally cut Moriba off, so I want to ask him a quick follow-up. When you look at, Moriba, when you look at space as an environment, what is the carrying capacity of low Earth orbit? How many satellites do you think we can safely get up there?
Look, I think it's a mixture of number of objects and the uncertainty with which we understand where they're at and where they're going to be. So it's a combination of things. For sure, you know, from the European Space Agency, we've seen a kind of a concept, the definition of orbital capacity and mission index, which is similar to an idea, you know, that I've tossed out there with like a space traffic footprint, which would be like a carbon footprint analog, some sort of composite index that brings in size, maneuverability, and all these things into it. I think in order for us to come up with, because look, the carrying capacity in the air, that's pretty common across the globe, but it wasn't always, right? It's like if you have better radar systems and that sort of stuff, the carrying capacity over your airspace is much better than over somebody who's just like looking outside the window with binoculars or something. So the thing is, we have to come up with what a standard observer and that sort of stuff is. And then based on these standard definitions, we can come up with a carrying capacity and say, look, let's define the carrying capacity as being exceeded when, I don't know, we experience 10% every month of losses, disruptions, or degradations of services that we can't prevent. Our decisions cannot prevent these things that are undesirable from happening. Therefore, the carrying capacity of this orbit has been exceeded or is saturated. And in the context of the carrying capacity, then I think we can start talking about allocating capacity in a way that is reminiscent of how the ITU allocates spectrum.
Thanks. And rather than ask the panelists directly more questions, I know we have a lot of great questions coming in on the chat. So I'm going to ask Rita to shoot.
Right. Okay, so from Joseph Sibera, apart from legal definitions of space junk, the junk will be made by private companies dominantly. Who is expected to pay for the removal? Public? What do the experts expect in this?
Moriba's probably got a really good response to this already, but so my feeling is that the companies need to take a leadership role. So spacecraft operators, especially the constellation operators, they are going to set the tone for how we behave and look after the space environment. And I think there are some really good strides being made by some of the companies looking forwards, looking at what happens if their spacecraft fail, how do we deal with this? So that I think that's first and foremost one of the best things that we can do is have these operators taking the lead in looking after the environment and using foresight to understand what problems might exist in the future. But beyond that, I'm going to defer to my co-panelists here to probably give you a bit of a better answer.
I have to say, Hugh, I love your answer. I think it makes a lot of sense. I think that governments need to step up in a major way. I mean, if space law kind of says that state parties to these treaties have liability over damage and harmful interference, and at the same time these states are the ones that have to provide authorization and continuing supervision of activities. I think the companies need to be beholden to the states that authorize them, and those states have to come up with their own national laws and enforce these things and hold people accountable, and do that in a way that's transparent, that shows the world that they are doing that sort of stuff. But I just don't see people rushing to do that.
And if I can, I would add to that and just suggest that it's through collaboration, it's through a unity and demonstration of behaviors by leading by example that I think we're going to achieve that. So it's very much to Hugh's point and to Moriba's point, it's through collaboration and having the confidence that we can actually achieve and demonstrate how we should be being responsible. So I think a lot of it is also in the constellation companies themselves and how they demonstrate that responsibility.
There's a couple of questions about the effect on our atmosphere. We're talking about the light pollution, but both, I think it's Jonathan Code and Deborah are asking questions about what happens to our ozone and our atmosphere as they're launching these satellites. Can any of our panelists speak to that?
So yes, I think from my side, being the launch vehicle manufacturer and having ambitions to launch from Scotland, part of our responsibility is actually to use such platforms as well to demonstrate what it is we're doing and why we think we are trying to demonstrate that responsible approach to launch. The fuel stuffs that we are using, utilizing hydrogen peroxide as the oxidizer, actually, as I'm sure a lot of people understand, produce a significant reduced carbon emissions for launch itself. So we're anticipating, I think, an average of a year's worth of launches to be less than an aircraft flight from London to Washington one way. So that's kind of the size of the emissions. We're also utilizing unrecycled plastic, so landfill plastic, as the base for creating an RP1 equivalent, so the rocket propellant one. So this is the kind of like the beginnings of the environmental standards that we're challenging ourselves with. We think that this is a reasonable place to start from, but at the same time, we believe that starting from this, we are looking to have continuous improvement and make a greater effect on contributing to net zero, to reducing the emissions and actually to making that happen. I think the second question also refers to a point that was made, I think, slightly earlier on in the discussions this evening about an environmental impact assessment for undertaking this activity in the Broad. And I believe, as I think we've heard already, there hasn't been one for specifically for SpaceX and the Starlink constellations that were put up there. And I think very much in collaboration with colleagues across the UK, Skyrora and other companies, and indeed with the support of people such as Hugh and Moriba, we are looking to try to challenge ourselves to come up to answer that question of coming up with an environmental impact assessment about the activity that we're doing, so that we understand exactly what the extent of the, delivering satellites into low Earth orbit, what the extent of having a space orbiting maneuvering vehicle would be, and how can we do it in a responsible way such that we can actually return and come back with some specific answers and share that with the more general public.
Does anyone else want to speak to that?
Yeah, look, I mean, at the end of the day, we need to do science. And the thing is, one of the things that I've seen, unfortunately, with time is, climate change people don't necessarily understand or even want to consider space, again, as an environment that needs environmental protection. And so that's an issue. And whenever people say, okay, well, if you want to know this stuff, you have to measure it. And so we actually need to get some science funded on this stuff. People keep on saying, you know what, that sounds really hard. Like, can you guarantee that you're going to be successful in the next 2 to 3 years? Well, no, because it's, science. Oh, well, it's like everybody wants off the shelf science, right? Science that will guarantee victory, where the line of sight of the return on investment is like in the 2 to 3 year time span. And it's like gone are the days when people just invested in science for the long-term return to just see, where does this go and what is it and what's going to happen. And so I'm very fearful of scientific investment these days because people just don't want to do it anymore.
I think if we just wrap up in 30 seconds to ask Hugh to say a little about his discovery that climate change actually has an effect on the lifetimes of space junk.
Thanks, Jonathan. So actually, not my discovery at all. So this is something actually that's been put forward several decades ago, in fact. What we've discovered is that the atmosphere where the satellites are operating is contracting downwards, so the density is decreasing. That's increasing lifetimes, not just of the operational satellites, but the debris. And that is effectively going to lead to a faster rate of growth of the debris population. And how fast? Quite a lot faster. I mean, the atmosphere is, as it turns out, is shrinking at a rate of about between about 6 and 10% per decade, which is pretty rapid. So we'd expect to see in 100 years' time, based on the concentration pathways that we're following, density where the International Space Station is at about 50% of what it is today.